Hello, good morning, everyone. This is the first session of the morning, so I'm going to try and make sure that you are awake. When I say good morning, can I get a good morning from the audience? Good morning. Yes, I like it. We are all awake, we are all here. I hope everybody had a good time yesterday and last night. Clearly, this crowd was not out too late, or you are still young and young at heart. Either one is just fine. There you go, young at heart. I like it. We've got some really, really great content coming up for you today on the Sandbox stage. It's going to be really fun. I've had a chance to preview most of these sessions, and there's some really, really good content, including coming up later, we've got a session on hacking airplanes. Anybody like hacking airplanes? Nice. Steve over there, he likes hacking airplanes. Steve runs the Aerospace Village. You should go check them out. We've also got a section on election security, one on entrepreneurialism. We've got some really good content. Before you leave today, and before you leave this week, make sure you fill out the survey. Tell us what you liked, tell us what you didn't like. We want to make this better every year for you. And also, at some point during the day, maybe between one of the talks, go and check out the Early Stage Expo. They've got some really cool companies, some really cool technologies over there. But before you do that, and the reason that you're probably all here, is to hear about the evolution of industrial cyber threats. Now, the next speaker is somebody I've known for many years, an incredibly smart, incredibly thoughtful, generous person. He is somebody who has spent many, many years working on this problem and has seen it change over time, has seen the adversaries escalate their capabilities, and the defenders escalate theirs. So coming up next to tell you all about that is the founder and CEO of Dragos Security, Robert Lee. Robert, come on up.
All right, thank you. Perfect, so thanks everybody for joining in the morning. This has been probably the most peaceful RSA for me ever. Since I shaved, just about no one recognizes me as I walk by, which is really nice. Every now and then I get a small shriek from somebody of, oh my gosh, it's you. So that's nice. While I've changed apparently my facial hair, I still have the passion for industrial, so we're kind of going to jump into it, and I'll get into the slides. But before we do that, I want to talk a little bit about what sort of happened in the industrial landscape to be overlaid against this cyber threat story, okay? I promise it'll be PowerPoint. You'll have to just sit through story time for a minute, though. The SANS instructor portion of that comes out. When you look at our industrial community, I get the question all the time, why? Like, why is things changing? Why now? Why are the threats being different? Has something happened? And in a lot of ways, there are very big changes in the threat piece, but a lot of the changes actually have come from our industry, okay? So when you look at the industrial community, and I would just say OT in general, operation technology, where it's going to be in data centers, airports, power systems, whatever, a big change that took place is probably 20, 30 years ago when you were dealing with these sites, you would have very heterogeneous environments, okay? A substation in California had very little to do with a substation in DC. Different integrators, different original equipment manufacturers, different physical profile. The equipment installed there was probably put in a different life cycle. The software used to make the software on the systems was very different. You'd have different network protocols. For those of you who've been in the field a long time, you'll have all seen like Bob's protocol somewhere, just some random developer figured out one way to open up a relay and used it. And they were very, very different. Now to take that electric transmission industry and talk about what a carbon cracker in an oil and gas environment would be like, completely different. So heterogeneous meant that we had very different types of ICS, very different environments, and there was not a lot of commonality between the industries and sub-industries. In that world, there's a con to that whole process. The big con is you can't really lean on a lot of outside expertise and help for what you're doing. There's not an ecosystem of people to go to. If you want to take these like fancy, you can't walk 5 steps without talking about AI at RSA this year kind of projects, can't do that on a highly diversified, heterogeneous environment. Additionally, it's very costly, okay? If you think about it from an asset owner and operator perspective, I've got to maintain this weird system. I've got to run it until it dies, 30 years from now. And the people that are trained on it, they're kind of stuck to that site. Like if somebody wants to transfer to another site or another industry, they get retrained. So it's not good for workforce development either, which makes it very difficult to get into sort of the scale of our industry and the people and the talent that we need. But also there's a pro to it. In that very heterogeneous environment, you end up having all the expertise. If something goes wrong at that site, something goes wrong at that plant, you know how to deal with it because all the expertise of that system and subsystems are in that plant. That operator, her daddy worked there 30 years ago, her granddaddy worked there 40 years ago. There's just generational and institutional knowledge on that site. So when something goes wrong, they can get root cause analysis, which is a major component of what we deal with in engineering and operations. It's not, well, we care about availability or safety. Everybody cares about safety. Not everyone actually cares about availability. Those are just easy ways to talk about industrial. They prioritize availability over integrity. Stop that. That's not actually what happens, okay? It's about the mission at that site and actually what we're trying to accomplish at that site, which may change in a wide variety of ways. But root cause analysis does matter. Because if something goes down, it's not enough to just get it back up. Because if I don't know why it went down, I could be restoring it into an unsafe condition. I could be restoring it in such a way that it's going to actually destroy or disrupt a part of the physical process. So it's not okay to just get back up and running if you don't have root cause analysis. Now this is not even getting into cyber yet. That's just from an operational resilience perspective. That's heterogeneous. In a homogeneous world, we end up having Codesys as a software stack that's inside of different PLCs everywhere. Modbus TCP, open standards, you have OPC, you have standard installs. Now the Emerson Ovation hydroelectric facility install is the exact same one as the solar concentrator farm. That Ovation system is going into different systems around the world, including oil and gas networks. The software that Siemens is developing is software that also has open source code shared with Honeywell. You get all of these homogeneous type aspects and you start to get cookie cutter installs and you've had consolidation. A lot of the smaller original equipment manufacturers get bought up by the largers. A lot of your smaller regional integrators get bought up. There's just a lot of similarity and standardization. The pro to that is we can now run industrial operations in the most efficient way we've ever been able to do in history. We can get better productivity. There are better safety and reliability standards. We talk about reducing the impacts on margins to be able to deliver services and goods at a lower cost but higher quality. It's a lot of good things. The downside is that expertise is now no longer in the company. If something goes wrong, we now have highly automated, highly complex systems of systems, and you've got to call on integrators and contractors and operators and all these folks to try to figure out what to do with those systems. So I got to lead the response side on the OT portion of the Colonial Pipeline hack. For those of you like, what OT portion? I don't know, but if there was no OT portion, why was I there? So I got to lead the Colonial Pipeline incident response on that piece, and they were calling people in off retirement to come and figure out how to restart portions of the pipeline, okay? That is not knowledge now that's just maintained at that site when you have a highly complex system. So that is our world right now, and that can cause problems long before we talk about the threat stuff. Let's take a quick case study. So a couple years ago, we had an individual power producer called us up because they had done a nice upgrade. They had done a whole new modernization on their combined cycle generation facility. So all they do is generate electric power, and they do it with big gas turbines, okay? And they took the gas turbines control system down for maintenance, all right? Normal process, every 6 months or so. They took it down for maintenance, and they were rolling the trucks in the morning to go do the maintenance. When they'd come into work, they'd found that the gas turbine control system had come back online on its own. That doesn't happen. Anybody that's ever worked near one of those things know that they don't just wake up in the morning and decide to start generating electricity. Okay, that's not how those work. So they were freaked out, and they tried to do root cause analysis. Why is this happening? What's going on? Everything was safe, but what the heck was going on? And they couldn't figure it out. There was systems of systems and complex are calling integrators and contractors and everybody else and trying to figure out what's going on. And they go, holy crap, maybe this is one of those cyber things those IT people are always talking about. So they called up their IT department. They called us from the response perspective. We drop our tech in, start looking around. One of our brilliant incident responders who's running around here somewhere, Leslie Carhart, was doing leading the case. And Leslie looked at the environment and said, there's no cyber-esque stuff to this. But the human-machine interface is kicking off a command to the PLC at the gas turbine, activating a control loop, and that's your problem. But nobody's at the station, nobody's clicking it, I don't understand. So Leslie went and took a look at it, brilliant idea, and said, hey, I know this is a NERC regulated asset. I can't load forensic tools and things onto it. But I'm allowed to use native systems and native tools, right? They're like, yeah. And they were like, cool, can you bring up Windows Paint? And the operators kind of looked at Leslie, be like, okay, Leslie's the expert. I've done a lot of incident response cases in my life. I've never used Windows Paint in an incident response case, so it was a little bit interesting. And Leslie said, okay, cool, well, let's go to lunch or something. This is going to take a little while. And they came back, there was black blotches on the screen. And what Leslie had picked up on was it had been upgraded to a touch screen HMI, and it was overly bright, and it was over-pressurized, and moths were getting in the building and hitting the screen. So when they got in the building and hit the screen, it just happened to be in the right location in the maintenance window to be able to click a button that actually activated the gas turbine control loop. That's insane, okay? So before we even talk cyber and threats, I've had US, Russia, North Korea, Iran, whatever in my threat model for a long time, but I've never had to have moths in my threat model, okay? That's where we are in the industrial world when you start talking about lots of automation, lots of complexity, lots of digitization and standardization. We are now experiencing operational resilience challenges that we didn't have to face 20 years ago. As a result, a lot of that cyber stuff that we talk about in terms of security, when done right, when it's things like the visibility of understanding interactions between systems, is just as effective for operational resilience and root cause analysis as it is cyber threats. Because if I can't figure out that the contractor changed logic on the controller, or I can't figure out that the HMI is kicking off a control loop, I can't maintain my facility. And if I can figure out that, I can probably figure out the cyber threat piece of it as well. So there's this OT security story forming in our communities these days that is less about do cyber because bad people exist, even though I'm going to get to that. And it's a lot more about let's just have operational resilience, and that's going to take a networked and digital component to what we're doing. And so I find that quite interesting. But as we get into the threat piece, let's see what that does to the threat landscape. If I'm in a highly heterogeneous system, it's very hard to do disruption and destruction. The more disruption I want to do, the more destruction I want to do, the more specific it's got to be to that site, okay? More destruction, more specific to the site in a heterogeneous world. I started my career on the Air Force side of the house, spent most of my time in the National Security Agency, did the ICS stuff there, went to Cyber Command where they did like offensive stuff, but I don't think we say we do offense. Let's just say I did free, unsolicited incident response for other people's infrastructure. So when I would do that, let's take a hypothetical, and I'm going to abstract out the details, of course. But let's say some military commander comes in and says, hey, Rob, I need you to be able to take down this site through the control system networks so that we can achieve some military objective. You need to go take down that site. Okay. And he's looking across the table at all the different options and capabilities, the pilots, the military folks on the special forces, the cyber people. He's like, I need to be able to take down this site. Who's got their options? Rob, what do you got? And I go, okay, sir, if you want me to be able to take down that site, I'm doing an OT cybersecurity attack, I'm going to need 18 months, team of 13 people, and $30 million. He's go, okay, how often can I use that capability? I'm like, oh no, it's specific to that site. You can't use it again. Could I use it to like similar sites? No. Could I even use it at that site again? Probably not. Okay. Turns to the pilot. Said, what can you do? Pilot goes, I'll be sober in 6 hours and I can just, drop a bomb on it. Every military commander is choosing that option. You end up having intelligence agencies be the only ones that are really interested in doing the type of stuff that we're worried about in a heterogeneous world. Military options don't wait around 18 months for one-time capabilities when they have other capabilities to use today. That's your world. That's your low-frequency, high-consequence world. We see a lot less stuff in OT security, but when we see it, it's bad. Low-frequency, high-consequence world. Now take that homogeneous journey. Now I've got things underneath the hood like code assist everywhere. Now, okay, hey boss, actually, I got a question. Can I have 18 months, team of 13 people, and $30 million to go develop a capability that you may not need right now, but you can use later? And they go, okay, how many times could I reuse it? I'm like, as many as you want. Against what targets? Anywhere, any type of industrial environment, it's fine. That's a credit card swipe, and it's getting done at governments around the world. So I used to stand on stages like this a decade ago and be like, calm down, don't hype us out. The phishing email is not taking down the grid. There's not one grid, and that's not how physics works. Dial it down a little bit. Now I stand on stages like this going, time's up. things have changed. We've taken that journey at the same time that our adversaries have, and we're seeing it with evidence, not anecdotes. That story about the capability that got developed, not going to talk about it today because I did it a couple years ago. In 2022, that was Pipedream. Pipedream is a capability that's basically just good engineering workstation software, and it is as useful on servo motors and unmanned aerial vehicles as it is on substations and gas turbines in manufacturing facilities. It is a completely reusable, scalable capability to do disruption, and if the physical profile allows it, destruction at almost any site in any industry on the planet, and it doesn't rely on exploits and vulnerabilities to do it. It's just using native functionality. That sucks. It's been out for a couple of years. You should take a look at it if you haven't already, okay? But let's talk now, after all the delays, because PowerPoint's interesting. My old head of Intel, Sergio Calderoni, used to say that PowerPoints and indicators of compromise have the exact same value, which is none, but you look stupid if you don't use them. So we're going to get into the PowerPoint now, okay? All right, so this data comes from our insights across customers, response cases, things we do out in the community. This is the 7th year of it. It's just a report we put out every year, just for free of, hey, here's all of what we're seeing. Here's the ground truth reality, let's go do something about it. And if there's not a problem, let's focus elsewhere because we have other stuff to do. And over the years, we've looked at this rise in these industrial threats. Each one of these icons just represents a different actor that we track or a different group that we track that specifically targets industrial environments. So it's not a state actor sent phishing emails at a power company. I don't care. That's IT, have fun. But if a actor tried to get into the operations technology side of the house or is explicitly showing the intent to do so, targeting the engineers, targeting remote access into the substations or manufacturing facilities or so forth, and it happens across a couple of different intrusions, a couple of different companies, they can become an icon in this chart. As far as the names go, they're all just industrial minerals. It doesn't really matter. In my view, attribution is absolutely pointless for basically everybody in this room besides government. You go, that's not true. All the vendors told me that I need to know that it's Russia, and like, that's fine, but that's just bullshit, so you do you. We just need to know that it's a group, and here's the tactics and techniques around them and what to do about it. But I'm going to patch this vulnerability faster because it's China and that one's Russia. No, you're not. That makes no sense, okay? So this is just about understanding how groups target industrial so you can learn from it. This past year, there was 3 new groups that we were tracking, and that ends up being something that we're going to look at over that curve. More interestingly is over this last 7 years or so, the groups that have stayed consistent. And so I want to highlight that there's some teams that have truly been quote unquote persistent. They're the folks that are not just interested in ICS for a while and then move on to something else. They're the ones that are learning, adapting, becoming more capable. Maybe they start out with barely being able to get into the OT, but a couple years later, they have the knowledge on what to steal and engineering workstation data and engineering drawings and HMI screenshots and so forth, and then progressing into the ability to actually do disruptive and destructive attacks. And we've seen that pattern. And here's why that's good for us as a community. In IT security, there's a lot of like, if you want to compromise that company, go forth and conquer. Go use Cobalt Strike, whatever else, good to go. On the OT side, there are groups, there are state actors that have no idea what to do in an industrial environment, and they've got to learn with all these weird systems and subsystems to be able to cause that kind of impact. And it's interesting because if you follow the weather forecast here, it's not, here's what's gonna happen, it's here's the path of the hurricane of the types of threats that are actually learning over the years, what they're learning. They expose the type of intent that they might have with how they target and where they target, and you can kind of get ahead of it a little bit. OT security, when done correctly, we can do more proactive things when we better understand our adversaries and kind of the direction that that hurricane is going. Now, the one that was probably most interesting to everybody this year was VoltSight. So VoltSight maps to what people talk about as Volt Typhoon. Volt Typhoon, that's great. They do a lot of other stuff inside that Volt Typhoon sort of group. All we care about is the OT portion. So we track it as VoltSight. And this is the group, for those of you unaware, that the United States government was coming out and sort of echoing really hard. You saw the FBI director, you saw Jen Easterly, you saw like the NSA director, everyone putting out lots of discussions about Volt Typhoon targeting electric systems in the United States, as well as some other key sites. There is a good portion of the community that's going, yeah, and? Like, why are you making a big deal out of this? We've been getting targeted forever. Dragonfly back in 2012 or 2013 was a campaign targeting electric systems, and he didn't have like presidential decrees. Why is this one so different? And that's a very reasonable question. And there's been various points in my career where I've come out and be like, hey, the government's hyping it up, calm down. They're not this time, and here's why. It's not that we're seeing living on the land techniques being used inside of operational environments. Yeah, okay, we've seen that. You want to do something about it, but that's not new. It's not that power systems are being targeted. Not new. It's not that they've done attribution to China and said, oh, it is China. I'm like, okay, still not new. What it is the very specific sites getting targeted, and the systems and subsystems and the data that was being targeted at those sites is very interesting in terms of the type of objectives that adversary may want to have. So it's less about this is new in terms of threats targeting you. It's more about this group was trying to get into the right systems and the right locations at nationally strategic sites to sort of embed themselves for future disruptive operations. That's not ideal, okay? That's what's different about it. And so I actually agree with the government's amplification. Now, I don't think you should send the same advisory out to the water sector and use it for trying to encourage water security people to do something. That's a little inappropriate. But the amplification from a government level of this is actually different, and it looks like China is getting ready to be able to do disruptive operations against key sites in the United States if, I don't know, like a conflict breaks out in China and Taiwan. That's more interesting. So I appreciate sort of the government's push on this. Now, when we've seen VoltSite, I do want to highlight the good thing, because I don't think we talk enough about the wins. This group was going out for multiple years targeting electric companies, okay? And we always talk about how, as a community, the adversaries, they just got to get one thing right, and defenders have to protect everything, which is completely false. Defenders actually just have to detect one thing well, pivot, and you can disrupt the operation there and at other companies. Adversaries are not as cool as you make them out to be, always. There's some cool stuff, but some people are like, oh, it's Russia's targeting me. It's like, it's not Russia. It's like under the SVR, there's a subgroup and a subgroup, and inside that subgroup, there's like 5 people that care about you. They got PowerPoint management, healthcare, and promotion status, discussions to talk about today as well. Like, they're still humans. You can do it. Defense is doable in this context. This is one of those defense is doable stories, and again, I don't think we highlight them enough. One of the strategic targets that China was going after, according to attribution of the US government, was this mid-sized electric utility in the United States. Mid-size, not a big one, okay? Not a well-resourced team in terms of like, they got all the things that a big investor-owned utility would have, just a mid-sized team. And that mid-sized electric utility was not doing zero trust and AI and blockchain and quantum, they were doing fundamentals. They were just doing the fundamentals like good network segmentation, trying to set up access controls, and they were doing the type of stuff that we would see in like the SANS 5 critical controls. They got to the point in their journey that then they wanted to do the network monitoring and visibility. So we ended up dropping our tech in and turning it on and going, you might have a problem here, and found out that they were compromised. But, and this is the key, they were compromised in the IT portion. The adversary was trying to get into their OT portion and had been trying for over 300 days consistently and failing. Okay? So I'm glad they detected so they could do something about it, and we should not have a mean time to detection ratio of 300 days. I want to get that down a little, okay? But take that for an example of a mid-sized electric utility doing the fundamentals and keeping a very well-resourced state actor that the government is actually caring about completely at bay from their objectives by doing those fundamentals. Good investment in people, process tech, training their staff, resourcing them to actually maintain the configuration on firewalls and segmentation. It was a really good story. And so a lot of times we hear the boogeyman is coming and we're all going to die. And I'm sorry to say, but there's some companies you're not doing anything and you should actually care about that. But the fundamentals can win and defense is doable. And I wish we would, as a community, would highlight more of these case studies. We also have 2 new groups, Laurinite and Ganonite. What was interesting about the Laurinite side of the house, and this is probably more interesting for folks in manufacturing, is instead of trying to just go after a remote access to get into a manufacturing line, this adversary very smartly was going after Oracle eBusiness and the iSupplier. So they're going after sort of the portal they use to be able to do not only their supply chain management piece, but you would have ERP-like systems that are important for actually pushing things down to the manufacturing lines, all right? So those type of systems hold the orders and sort of what is supposed to be produced and when, which has a direct access now into that new digital and connected manufacturing suite. So the adversary was targeting that portal to be able to pivot into not just one site, but all the different manufacturing sites they had at all the OT places through your big, nice segmentation projects or whatever, just directly using their own software. So it was a really, really clever thing that they were doing. We've been worried about that for a while. But again, the adversary is using open source tools, public proof of concept exploits, known vulnerabilities. All right? Again, I'm glad that we talk about things in the future, and there's probably really good use cases of AI, but I really want to caution people from going, there's AI-generated attacks, and look, you can't defend against it. Like, all the threats we're talking about, every single one we see is public POCs, known vulnerabilities, known tools, open source tools, et cetera. There's some pipe dream-like capabilities out there. You should be careful about. You should know them. You should track them. But 9 times out of 10, it's the stuff that you can do with any of the type of efforts we've talked about for the last 10 years. You just got to go do it. And if you put those fundamentals in place, you'll be okay. Ganonite. Yeah, credential phishing, domain masquerading, okay, got it. But then dropping in remote access tools directly into electric, oil and gas, transportation, manufacturing, and defense. Everything they were focused on was espionage. This is not a group I expect to be spinning up into a disruptive operation letter. But a lot of intellectual property inside of these industrial environments is not just about the recipe, okay? The intellectual property in new industrial environments is your industrial automation. How did you put it all together to create a more efficient process? How did you take lower quality inputs and make higher quality outputs through that digitization and that automation? That is highly sensitive, highly valuable intellectual property, and there's various state actors that are stealing that left and right to go spin up companies to compete with those companies. So it's very important to recognize the most core part of your company is the OT. That's the critical part of critical infrastructure. That's where you generate revenue as a company. And the core intellectual property for a lot of your digitization, Industry 4.0, or whatever kind of journeys is the automation itself. So be very careful, because companies will be going out of business when their competitors come online doing exactly what they've done at a cheaper margin. As we move on, again, there's threat groups that have been active over the years. Comosite and Electrum were the ones that were active in Ukraine. So I got to deal with the 2015 Ukraine outages and dealing with the response on the electric power sector there. Then it happened again in 2016, and then a couple more times since then. Electrum's been the group that's been doing that. Comosite is the knock down the doors team. So they go and they get access to the site, and then they hand off the access to Electrum, who does the disruption. So it's a very clear example of 2 different teams working together, likely in the same government agency. And what I want to highlight here is, yeah, the 2015 attack happened, and the 2016 happened, and then the 2023 attack happened. Everyone goes, yeah, that's in Ukraine. It's in Ukraine for right now. So what we've seen and what we can prove with the data is a wide variety of the groups that we were tracking that may have been connected to Russia in some way. Again, we don't really get an attribution. But a lot of the groups that we were tracking prior to the Ukraine war were focused with global footprints. When the Ukraine war kicked off, all those groups, like Eye of Sauron, went back to focusing in Ukraine. That war is not going to last forever. When that is over, these groups that we're talking about very likely will then pivot back into what they were doing before, which is their global operations. But now you're going to have teams that have a lot of experience doing disruption and destruction in a conflict scenario on industrial infrastructure. So Electrum in 2016 and 2017 was already a group we were concerned with. When they reemerge from going through all of this expertise, they're going to be someone that's very, very capable, probably one of the most capable teams on the planet. Even as the ex-NSA guy, I'm like, yeah, NSA is not getting the battlefield experience that these folks are getting over a long period of time. It is going to be a different discussion later, and I want us to be careful of that. Of course, we also have like the hacktivist groups and so forth. I think this came up a lot, sort of from a media perspective of, look, there's water facilities that were getting compromised. I can understand people going, yeah, so what? It was internet-connected control systems. This isn't that big of a deal. It is, because there's a lot more internet-connected control systems than you think. But it's actually not so much of a big deal of, look, they went after that water utility. To the people in that town it is, by the way. But I can understand where a lot of the security community kind of turns off from that. But here's why it actually has a geopolitical kind of context that's important. For the last decade plus, in tracking these threats, none of them are actually getting to U.S. infrastructure to do disruption. It's for future disruption. It's for espionage. It's for capability development. There was no like, let's cross the line and take down any infrastructure. And I don't know why, but the assessment is there's a certain fear of retribution, a fear of something coming back at them in consequence for disrupting U.S. infrastructure. But all along the way, we've consistently showed that there is no such red line. Ukraine power systems go down, nobody says anything in 2015 or 2016. I remember the discussion that they were getting ready to brief the president. They were advising the president to come out and say something about it. And he was like, the American public are not going to care about something happening in Ukraine for a cyber attack, and they decided not to say anything. When you make those choices, and you never even say anything, let alone do anything about the various attacks we're seeing, there's no credible deterrence, there's no credible red lines. So adversaries become emboldened, and they start doing more, and they start having more effects. What's different about this is not internet-connected systems. What's different about this is 2 water utilities, and I think now more, 2 water utilities had a group in Russia, so a criminal group that's identified themselves as being affiliated with Russia, cause impact at those water utilities, overflowing tanks, causing disruption. So you actually had ICS proper attacks taking place on US infrastructure, and honestly, like, not a damn thing was said about it besides like an advisory. So this group claimed to be from like Iran, but then like the Cyber Russia team then claimed to be from Russia. Both of them, I think there's a little bit of like, don't believe too much when the criminals tell you things. Sometimes criminals lie, but there's an interesting overlap. The one thing I will highlight was the Cyber Russia Avengers one. I think the Cyber Russia team won. There have been people that came out and said, this is Sandworm, and you may have seen that sort of advisory. I will tell you, with my experience having worked that team, I don't think it is. So I'm going to be very careful of sort of drawing those connections between Russia, the state, and Russia criminal groups. The thing that is interesting, though, again, going back to that geopolitical view, is we're now seeing state actors tell their criminal groups, you're unleashed. We won't have consequence for you going and doing those types of things. So I think it's a big leap to say Russia government tasked these criminal groups to do it. I don't actually think that's supported by any of the data that I've seen, but it is very clear that somebody told them, guns free, feel free, do what you want. And now we're in a very different place again in terms of infrastructure. So what about lessons learned from getting out in the field? This is probably not the sexy parts of the report when you don't talk about threats, but in my opinion, some of the most meaningful. How are people actually doing? Now, please recognize there is a bit of a bias. The type of people that come to us to use our services for assessments are already going down the journey. They're already generally more mature clients to be even having those conversations of OT-specific work. So this is of mature clients. This is the data. I will tell you from what I know about the non-mature clients, the people that haven't started going down their journey, the data skews very, very drastically, okay? So from the larger data set and of more mature clients, and so the folks that think they're doing it right to start with, 28% of the time the firewalls are massively misconfigured. And I don't mean there's a misconfiguration and so we put it in the data set. I mean that it is as porous as Swiss cheese to go from IT into OT, okay? About 28% of the time, it might as well not be there for an adversary to pivot into operations environments. 28% of the time, folks are putting not the right type of network segmentation in place, again, to cause any sort of slowdown there. Why is that important? When you look at the guidance out to the OT security community, historically speaking, NIST cybersecurity framework, IEC 62443, advisories from CISA, CPGs, everything else, about 95% of that guidance, and we actually did the math on it, but about 95% of that guidance is preventative in nature. Patch, passwords, access control, segmentation, antivirus, application whitelisting, it's all preventative. So that is telling asset owners and operators that about 5% of the resources should be spent for identification, detection, response, recovery. So you see a giant prevention bias in the industrial community, not because they're idiots, but because they're following government standards and guidance. That means that when you have giant issues like this 28% of the time and mature clients, you're not actually even getting it done. It means you have no chance on the rest of the stuff because that stuff isn't happening either. We need to even that out a little bit more to be able to have a more robust profile of detection, response, prevention, and recovery. 1 in 10 still share their authentication domain architecture. It is a much higher number in the more digital communities like manufacturing. Why that's an issue is most of the ransomware cases we take is a ransomware group hit the IT, got on the Active Directory or domain controller, and just rode that stuff down into the operations environments. It's not even that they were intending to target the operations environments. However, what we are seeing with those ransomware groups is now that they're hitting those sites, and they don't know what it is. They're like, that's that weird automation stuff. I don't know what OT is, but when I hit it, the company pays more and pays faster because the revenue's down. That's interesting. And so we're starting to see that cycle, not of ICS expert ransomware groups, but of ransomware groups using that type of infrastructure to get down to those sites to target the operations side. For those of you who are like, yeah, okay, well, I keep hearing these companies go down and they said it was only in their IT. Please understand that people aren't lying, but there's a very, very broad gap in what people call IT and OT, okay? OT is not about an operating system. OT is about what's the mission function of it, the purpose, the control loop, the actual physical process, components around it, et cetera. We have Windows operating systems and power plants, okay? People talk about IT, OT convergence as if it's coming. It happened like 15 years ago. It doesn't change the discussion. Now you're experiencing more connectivity and digitization, but the convergence already took place. OT is still different from the mission function, the impacts, the consequence, the ways to target, et cetera. Why that matters though, is most response firms and a lot of the security teams of these companies getting hit, look at it and go, oh, it was a Windows system. Yeah, it only impacted our IT. It's like, that was an engineering workstation and brought down the factory line. Yeah, but it was a Windows system, it's IT. Like, no, man. So a lot of the news you hear and a lot of media reports around this was only impacting IT. We've worked some of those cases, and I will tell you without picking anyone out, they're OT cases, but they're just getting flavored as if it only hit IT because Windows systems were hit. Now, what does this mean again from ransomware attacks in the industry? It looks like the ransomware groups just don't like manufacturing when you look at this data. It's not true, it's not the takeaway. When you look at the 638 cases, or actually much more than that, I think it's about 900 cases. When you look at the cases of ransomware this past year, 638 of them were in manufacturing, which is by far, 10 in renewables, 10 in water, 30 in oil and gas, like 638 stands out. Why is that taking place is an important takeaway and lesson learned for all of you that are not in manufacturing. Why this is taking place in my assessment is because manufacturers were the ones that take the digitization, standardization, homogenous journey faster. Why? They had to. To be competitive on a global stage, you had to be to razor thin margin accuracy to actually be profitable versus going out of, and becoming bankrupt. So a lot of automation, a lot of industrialization, a lot of digitization, a lot of standardization happened in manufacturing a lot faster than anywhere else. So for oil and gas and electric and everybody else looking at that, don't go, oh, that's manufacturing's problem. Look at them like the canary in the coal mine. That's where your companies are going. And if you don't get ahead of it, you're going to have those kind of stats as we do these upgrades. I testified to the U.S. House Oversight Committee a couple months ago, and they were talking about the water industry, and they were like, what worries you about the water industry? I said, right now, it's a lot of more analog, disconnected systems. It really is. They're in the smaller co-ops and municipalities in your town. But the vendors won't support that going forward, and those upgrades are happening. We've had infrastructure bills and similar. We're going to start seeing those upgrades happen, which is good by all means. But the vendors will only now sell them the new automation equipment, the new connected equipment, the shared services, enterprise, et cetera. And so your water industry, not this year, probably not next year, sometime within the next 4 to 5 year upgrade cycle, you're going to start seeing these kind of attacks on them as well. So again, not, I want to predict the future, how could I? The threats get a vote on that. But just, hey, from what we've seen from other industries, what we've seen from the past, here's the very clear forecast of what is reasonable to expect as a result. So that's where I want people to kind of think in advance, because you don't roll out an OT security project in a month like you can get done with an IT project. It's going to take a long period of time, usually a 2 to 3 year journey. So it's best to start a little early for those that actually care. On the ransomware groups, again, I wouldn't be chasing every single indicator of compromise and thing related to ransomware groups. Honestly, 25% of the ones that happen in an industrial organization were lockbit. So it's more about, okay, well, what are the tactics and techniques that group is using? And we've got a big swath of the problem taken care of. It's absolutely much more about behaviors, the methods, the tactics and techniques that you need to focus on. That's what's going to get you in a good place, and then kind of have that trickle-down effect for the other groups that you don't know about. The vulnerabilities one is really interesting to me every year. So we have to go through and correct the vulnerabilities. Now, there are some really good product security teams at the original equipment manufacturers that do a darn good job. A lot of the majors do a really good job. But there is still a massive problem on the vulnerability side in OT compared to IT. And I don't mean in the number. What I mean is there is issues, lack of standardization, and just a big misunderstanding of how to deal with vulnerabilities. The vulnerability disclosure process is terrifying with a number of these folks. And the errors in the vulnerabilities are significant. Each year we find that there's 20 to 30% error rate in the vulnerability disclosure that goes out. Wrong CVSS, wrong hardware, wrong software, wrong version, wrong exploitability, something wrong in it. So if you're an asset owner and operator, about 30% of the time, even if you want to do something with the advisory, it's got wrong data in it. Further, we find that the CVSS stuff means nothing for OT security. Prioritizing on CVSS inside of ICS or OT environments has absolutely nothing to do with the impact or risk or anything that you should care about inside of an industrial context. So when we look at it, we go, look, what's the operational impact of this vulnerability if it had been exploited? Is it cause a loss of view? Does it cause a loss of control? Or does it cause neither? Does it cause both? In this past year, we ended up having 46% of all the vulnerabilities not cause a loss of view or control or safety or anything at all. They're just interesting vulnerabilities for like a DEF CON presentation. They're nothing an asset owner and operator should ever care about. And that's 46% just like right off the bat, okay? We then further try to figure out what can we do about that vulnerability to see if it's even useful to people. So our Intel team goes through every single one of these vulnerabilities and then kind of after the correcting them, figures out what is the mitigation advice. And we find that 73% of the time, there's no practical mitigation advice at all in these advisories. I'll let that sink in for a second. So I'm an asset owner and operator. People are coming to me and saying, you have vulnerabilities, fix them. 30% of the time, the data is wrong. And 73% of the time, there's no guidance on what to do with it. That's not asset owners and operators being assholes. That's them just not being able to do this, okay? That is a hard challenge to do. So one of the things that we do is we go through and we put them into the Carnegie Mellon prioritization, which we really like, which is now, next, never. To be in the now category, it causes loss of control, loss of view, some kind of impactful loss, or it is actively being exploited by adversaries anyways, so our opinion doesn't matter, they're using it, it counts. Either one of those things gets it into you should take care of this now, and this past year it was 3%. The year before that was 4%. The year before that was 4%. Every single year, about 2 to 4% of the vulnerabilities are the only ones that are driving enough risk to say you should go address this now. So you should go talk to your executives and boards or whatever else. Don't have a KPI on how many vulnerabilities you have and what you're patching. It's the wrong metric in OT. It's 3% of them matter, so how long do we actually deal with that mitigation? But 68% of them, you can just monitor for. You don't even need to mitigate it with anything else other than monitoring. Or if you want, next opportunity that you have and you're just like really worried about it, feel free, maintenance cycle or whatever. But 29% of the time, they're useless. You should never touch that vulnerability. Even mitigating that vulnerability introduces more risk to operations than any risk posed by any possible adversary. So let this sink in for a second. A lot of IT folks, when they come into OT the first time, they go into the plants, they go, oh, they have Windows XP. There's vulnerabilities. And it's just not that impactful. So I'm not saying don't do vulnerability discovery. I'm not saying don't fix vulnerabilities, but do it well enough to know what the 3% are. Fix those. And what a great story for security to go to operations to say, hey, based on the tooling we've done, the people, the process, understanding your mission, et cetera, 97% of all the vulnerabilities out there, and you've got 30 years plus of equipment, so it's a lot, we're just gonna take off your plate. We've done the analysis. 97% of that stuff, we're just putting into a corner, we're not gonna bother you on. But the 3%, when we come to you, we need your help. That then helps with that IT-OT clash. It's not 62443 said, and therefore, and ooh, you have vulnerabilities. It's, oh, we understand that you're the reason the company exists. We understand your mission. We did the work ahead of time, and we're keeping 97% of the trash off your plate. That's a great build bridging exercise inside of industrial. Now, the next one I want to highlight is about private-public partnership, because we all hear that word all the time for years. And I was always looking for like, well, where's the case studies of this actually being meaningful? And we finally got one, I think we have two now, but I finally got one which I really like. So I want to give credit to the US government on this one. So the US government used their sources and methods, not that hard to figure out, they used their sources and methods to go find that a certain state actor, that you couldn't be wrong in guessing, a certain state actor was developing capabilities against unknown Rockwell vulnerabilities, okay? It wasn't just, here's an exploit. They were developing capabilities. They were looking to do disruptive attacks against these sites that they were going after using this vulnerability in the Rockwell equipment. So the US government finds that with their sources and methods, and instead of overclassifying it and whatever else, they bring in Rockwell and Dragos. They say, hey guys, Rockwell, it's your equipment, and Dragos, like you have these insights, why don't you look at what we're looking at, and you tell us what you think, and we'll tell you what we think. And it was true collaboration in the way that we've always talked about, at the right time. Then once we had a broader picture formed of this is what it is, and we started using some of our systems and data to go, hey, is this even present in the United States? Like we went into a system we have called Neighborhood Keeper to go, do these vulnerabilities even exist out in the United States? We're like, oh yeah, they're actually pretty active in these different locations. Now the government understands if it's a priority or not for them, because they don't have those insights normally. And then we also have the ability to go, well, let's just put out the mitigations to our customers now, and hey, the mitigations we wrote, because government, you brought us in, and we don't just want to like play favorites, let's hand this back to you, and in your advisories, you can go tell all the other vendors about it to help out everybody else. And so because of what the US government did and how they coordinated it, they understood a realistic threat to the US systems ahead of the attack, coordinated with the right people in real time and not overly classified, pulled it all together, and then brought in all of the other security vendors that they work with, and pushed out, everybody was able to push out mitigations and advice and insights to every one of the customers of every single one that's in that ecosystem before you ever read the press release about it. Like, that's what right is supposed to look like. We all talk about it all the time. It never has historically really happened that way. So I do want to give the US government like a huge credit on this, because this is exactly what we've been asking them to do for a long, long time, and they nailed it. When we look at tabletop exercises as sort of incident response preparedness, there's also just some interesting themes that come about with these companies. If they don't do a lot of if they do a lot of prevention, like, can they get to the response? Some are doing a great job, but what I would say is the guidance coming from those standards and similar is still pushing things like detection and response down. The trends are there for those decreasing in favor of what are you doing about segmentation, what are you doing about patching, what are you doing about architecture. And so I would just say, again, we really need to reinforce that if you're going to be able to deal with a response, you need to have systems and things deployed ahead of time. And that sounds like a dirty vendor pitch. It's just the reality. In an IT world, you can call up CrowdStrike or Mandiant or whoever. You hopefully prepared ahead of time, but let's say you didn't. They're going to come in, they're going to drop Falcon as an example in the system, pull all the data from the system, and they're going to be able to do a good job, okay? You want to prepare ahead of time, but automation and productization and the skills of the staff have gotten to the point, you can still fumble through an incident response and do okay and get the questions you need answered in IT. Because in IT, it's a world of systems and data. But in OT, it's a world of systems and physics. And so it's not about pulling the forensics on a host. It's about understanding the Yokogawa VNet IP protocol that went from the engineer workstation to the controller and what it did. And if I'm not collecting that at the time that it happened, it's gone, because it was networked, it was transient data. So you got to put stuff in ahead of time. So what we're finding most in these assessments is that the questions the board has, the SEC might have for 8K and 10K filings for public companies, the lawsuits you might deal with, the data the operations people might have, the 20 questions that are going to need to get answered inside of that incident response are not getting identified in advance. So the security team doesn't know to go map that to the data they would need. And what we find is, on average, you're only going to be able to answer 1 or 2 of those 20 plus questions in the incident if you didn't actually prepare ahead of time. So there's a lot of companies that think they're in a good place because they have retainers, they have tabletop exercises, they've done all the prevention, they followed the guidance, and they are screwed when it comes to the response piece. A lot of times when we do incident response, it's professional like counseling and therapy more than it is actually doing the incident response. It's, but I thought we did all these things. No, you did a lot of good things. The teams aren't stupid. You followed the guidance, but the guidance hasn't been updated to get to where you need to go, and it's not very OT specific. And that is a hard conversation to have with really good people who are actually putting their hardest into it. So what do you do about it all? Then I'll get off the stage. My view is the 5 critical controls. So I still teach at SANS, so I authored the ICS 515 class there. Been doing that for the last decade or so. I still go out and teach a couple times a year. And consistently at SANS, our students will come to us on the ICS side and go, what do I do? Like, what does right look like? I see all these standards, all these frameworks. I'm bought into the fact that I shouldn't just play bingo with a standard, but there's no like strategy. It's just, did you do this control? Did you do this control? Well, I have 167 OT networks. Like, which ones do I do it at? What data am I supposed to collect? They say, like, you should do monitoring. Monitoring of what? Like, I just don't know what to do. And so the critical controls project from SANS originally that was at 20 critical controls, it sort of asked us as well, like, well, what would be the ICS critical controls? So Tim Conway, who's a fantastic SANS ICS author and operator, had been electric grid operator for the past 20 years before that, he and I sat down, and we didn't want to have our own bias either. Like, I like instant response, and so it'd be like, oh, instant response, do that. And I didn't want the bias to bleed into it. So what we did is we looked at every single industrial security attack that we have access to, all the known ones, all the private incident response ones we have access to, the personal cases that we worked. We looked at every single industrial security attack that has ever taken place, and we just put them all into a sort of spreadsheet and said, look, what security controls would have been effective in all of them? Not 1, not 15%, not 30%, but what are the security controls that were effective in all of them? And if they're effective in all of them, that's a fundamental. That's a critical control. So let's do those. Not saying don't go do more things if you want, but you immediately start getting into the land of maybe gold plating the problem. But I am saying you got to at least be doing these things, or you are undersizing the issue. Well, we have nice segmentation, and now you got to do all 5. All 5 are actually effective in all these attacks. So we did that. This is the answer we got. It first started with an ICS incident response plan, but that's not here's a plan, an IRP, or whatever else. It's what are the scenarios that actually matter to our company? If I'm an electric power company, Should I really care about the Trisis attack in Saudi Arabia in 2017 that targeted the safety system to try to kill people? Probably not. Like, should I learn from the tactics and techniques if I got the time? Of course. Let's be proactive. But let's not miss the fact that ransomware and OT happens a lot in electric. Electrum, what they did with the crash override or in-destroyer malware, taking down electric power mattered, and that pipe dream thing mattered in the electric industry. Let's start with those 3 scenarios. Those 3 scenarios then tell us, how do we need to respond? What data might we need? What is the architecture, a defensible architecture, what does an architecture need to look like against that set of risk? And now when I go to the operations staff, it's not, I'm doing this because of a standard, or I'm doing this because of compliance, or I'm doing this because I think this is a good or bad control, and it's like, dude, it's not an ethics discussion. Is it relevant or not? Now you come in and go, look, we've got alignment that these are the things that actually can impact operations here, alignment from board on down, and this is how we need to deal with that. Now it's a conversation you can have that guides people in the direction of requirements instead of just throwing out, I like this security tool. That, again, informs the defensive architecture. It informs where you're monitoring, what data you need, how long might you need that data retention, what sites are in scope. It's probably not 100% of your sites. If you're a company that's got 400 global sites, you're probably not doing everything at all 400 at once. You probably shouldn't do everything at all 400, period. It might be, hey, the top 32%, based on health and safety data, revenue numbers, whatever, we need to do all of this. You know, the bottom like 15%, they don't generate enough revenue for us at all, maybe we'll just have an incident response plan and a firewall. You will end up tailoring the strategy based on your actual risk, based on the scenarios of what are the threats actually doing, in a way that everybody understands. Boards understand scenario planning. Cyber people understand like kill chain analysis and scenarios. Operators understand scenarios like process hazard analysis and HazOps. It's a common language to speak across business, operations, and security against real requirements driven by threats and what they actually did. It's not, I went to DEF CON or RSA and I saw that there was a vulnerability that allows me to take this, activate Bluetooth, and spin a wind turbine backwards and it catches fire. We need to mitigate that. It's like, dude, has it ever happened? Well, no. Well, then let's focus on the stuff that has, okay? That's nice. I'm not saying don't be proactive. We got some stuff to do and it's going to take a while. Let's do the things that actually have mattered. Well, here's what I would do. Yeah, but here's what the threats are doing. So let's start with what's actually taking place, then do the rest. So anyways, that's my time. You can go through all of these. The paper's out there. Again, secure remote access you're going to need to get to after you actually know what's in your environment. Please stop rolling out your secure remote access projects without doing asset identification. You just end up having all the exposure that you had before. And then on risk-based vulnerability management, it gets down to like that 3%, not the 100% of vulnerabilities. Now you got a program, and then you can map it to 62443, NIST cybersecurity framework, or whatever else as the lexicon you use. So thanks so much. I'm going to hang around in the back for questions. I don't want to like take questions on stage because somebody will stand up and be like, hey, I don't actually have a question. I want to make a comment, and then everyone groans. Like, I'll be back there to be able to hang out and chat with everybody for a little bit and then head out. Thanks for your time today. And most importantly, before you applause, but I appreciate you, please remember, in our communities, this stuff matters a hell of a lot more than our opinions and the cybery stuff and whatever. Like, my kids depend on the water infrastructure in our town. If you're in IT and you're thinking about getting an OT, I promise you the mission is cooler here. IT people are cool too. You're important. Everybody loves you. But this shit is our local communities. Put some focus on it, okay? All right, thanks, folks.